This is the 6th lecture on WinLogy Lab. In the last lecture, we saw the tool WinExpresso. In today's lecture, we are going to explore the tool WinCounter. It's a tool used to design and analyze the binary logic state machine counters implemented via digital flip-flops and logic gates. Now let us explore the tool WinCounter. Now here we can create a new counter using new counter design or new counter analysis, and even we can load a previously saved file. First we'll see how to create a new counter using new counter design. Here also we can change the number of variables. Number of flip-flops I'm considering as 2. Even we can change the flip-flop modes. I'm keeping it as it is. Now this is the state transition table consisting of the present state, next state and the control functions, that is toggle flip-flop B and toggle flip-flop A. The state transition table is used to design a flip-flop counter circuit. In this case, a user desired count sequence is required to be implemented by a circuit. Now here in next state under hex is the count sequence which I want to put for my counter circuit. Now the next section is of K-map output. Using K-map, the equations are obtained for TB and TA. Next is the counter circuit. This is the counter circuit that is being drawn using JK flip-flops as T flip-flop. Then the NAND circuit, and then comes the transition diagram and transition table. This is the transition table consisting of the present state, control functions and the next state, and this is the transition diagram. Now you can either print or copy the transition table or transition diagram. Now let us create a new counter using new counter analysis, wherein we have to create a counter and then we have to analyze it using NOT gate, AND gate, OR gate, XOR gate, NAND gate, NOR gate and XNOR gate, and wires. We can even change the number of variable names and everything. Here I am keeping my number of flip-flops as 2 for simplicity. Now we have to connect it using the wire. Again, I am considering simple connections. Once I am done with connections, there is an option solve display circuit check. That means our circuit is correct, all the connections are made. Then Boolean functions. These are the Boolean functions for flip-flop A, J and K and flip-flop B, J and K. We can either print the function or copy it to clipboard. This is the transition table for the counter design we made, and this is the transition diagram for the same. We can either copy this or print this. In today's lecture, we design counters as well as we design counters using state transition tables. In our next lecture, we will be focusing on our next tool, that is state machine. Thank you.